Okay, let's look at some algebra. First, we need to understand about pronumerals. Pronumerals are letters that we apply in mathematics that represent a value that either we don't know or may change. So for example, we could use the pronumeral x and give it a value. So it might be equal to something like the number of hours worked or the number of lollies in a particular packet. And then we can use x in an expression or an equation, and that allows us to manipulate it without actually writing the value out each time. Right, let's look at an example using the x. So if we take, for example, a bag of lollies, and we don't know how many lollies are in the bag, but we're going to say that the number of lollies that are in the bag are equal to x. Then what we can say is, well, what if we got the bag of lollies and then we got 3 more lollies? We could then express that as x, so the number of lollies in the bag, plus 3. So this becomes what we call an expression. Right, so then, for example, let's say if we know that if we count up all the lollies in the bag, plus those 3, and let's say that equals 10, then we can say that x plus 3 equals 10. Now, once you get an equal sign in there, this becomes known as an equation. And obviously from this, we could then work out that, well, something plus 3 equals 10, so therefore then we would know that x equals 7, and we would then know that the number of lollies in the bag is equal to 7. Let's see if we can manipulate it in a few other ways. Okay, so we got our bag of lollies, and we're saying the number of lollies in the bag is equal to x. And now we add another bag of lollies. So we've got x for the number here, and this would also be x. So this would be x plus x. And x plus x, just like if you said 1 banana plus another banana, or 1 orange plus 1 orange will equal 2 oranges or 2 bananas, x plus x will equal 2x. Now, what we know from this is that that's 2 and it's multiplied by the x, like this. And this multiplication is something that we don't write when we're doing algebra. What we do is we have this expectation that whenever we put a 2 before the pronumeral, or a number before the pronumeral, then we assume that there is a multiplication sign in here. So any number that goes beforehand, this is known as the coefficient. Okay, so x plus x equals 2x. And then imagine that we have these 2 bags of lollies, which we now know are equal to 2x. And we get 3 more lollies, 1, 2, 3. So we're going to add on those 3. So now we've got 2x plus 3. Now let's assume that if we counted all the lollies in the bag, and it's the same number in each of these bags, plus the 3, let's assume that that gives us a total of 17. Then we would know that 2x is equal to, take the 3 away from here. So take the 3 away here, take the 3 away here, will equal to 14. So then we would assume that x equals 7, like this. So in this way we can manipulate the x, and we manipulate the numbers based upon the information that we've been given. All right, we looked already at the idea of x plus x equaling 2x, and we know that there is a multiplication sign that's in here. We know that this 2x represents 2x equals 2 multiplied by x. A couple of things to note here, and that is that when we're doing our x, this is a multiplication sign and this is an x. The reason for that is we don't want to confuse one with the other. So we always want to make sure we're doing our multiplication sign with just these slashes, and we're doing these X's in this cursive style. And you'll certainly see that printed in textbooks that way. Let's have a look then at division. So if with multiplication, we can do this and not have it included. What we can find with division is that we can express division and get rid of this division sign by turning it into a fraction. So 2x divided by 2 is 2x divided by 2 in this format. And we always want to try and move our algebraic expressions or equations into this format. And that will make it a bit easier for us to simplify things like cancelling the 2 and leaving x and that type of thing. All right, let's have a look at a question here. So Simon has X fish in his aquarium and he buys 10 more. How many fish does he have now? Now, one of the problems with this type of question that students come across is that they think that they're going to always end up with a number answer. And this is an algebraic answer. So you're not going to normally say, oh, he's got 35 fish or he's got 52 fish. You're going to end up with an algebraic expression as your answer. So we've got to think in that way, that we're not after a number here, we're after an expression. So he started off with X number of fish, and then he added 10 more, and that becomes your answer. All right, let's have a look at this question here. There are cards in a deck. How many in 3 decks? A couple of things here. Firstly, you'll see here, all of a sudden we've got a new pronumeral. So it's R, and a pronumeral can be any of the letters of the alphabet. We typically try to stay away from some of them because they have meaning in other ways. So we try to stick to things like X and Y and Z. You'll see M and O P, and often you'll see that the letters that get used are grouped together in the alphabet. So if A gets used, then B and C and D will be the next ones to get used. You don't typically see it where there'll be A and X, or L and Y and things like that. So they're typically grouped in that way, just so that you know that they are pronumerals, and it allows us to differentiate it from other things. Secondly, this question asks you about how many cards there are in 3 decks. Now, a lot of students are going to go, oh, I know how many cards there are in a deck. There's 52 cards in a deck, and they're going to try and go 3 times 52, and that will be their answer. That's not what this question is asking you. This question is asking you for an algebraic expression as the answer. So you've got to think along the ideas of this. It's a multiplication question or it's a multiple addition question. So there's really 2 answers to this. One would be R plus R plus R, and the other one would be 3 times R. Both of these will give you the same outcome though. R plus R gives you 3R, and 3 times R gives you 3R. So 3R would be your answer, and this would be your proof. Okay, so Sonia has N dollars in her bank account. So N is our pronumeral in this case. In her bank account, she withdraws $100. So withdraws means subtraction. How much money does she have left now? Again, you're not after a dollar amount, you are after a expression. So here we want to have N, and we're taking away 100, and that becomes our answer. Now, sometimes with things like this, they will then say, there'll be an additional bit of information and say, if she started with $1,000, how much does she have left? And so you would substitute that value in for N. But if it doesn't give you that amount, then the expression alone is your answer. All right, so there are D biscuits in a pack. All right, so D is our pronumeral, and if half are eaten, so to get half of anything, it's divide by 2. So our expression here is going to be D, and we're going to divide it by 2. And within division part of a algebraic expression, we want to turn that into a fraction, so D over 2 becomes your answer. Okay, so a kitchen cupboard has X plates, so X plates and W bowls. So in this question there are 2 pronumerals. X refers to the number of plates and W refers to the number of bowls. How many plates and bowls in the cupboard? So this is simply an addition. The and is an addition, so we've got X, and we want to add on the W, equals the number of plates and bowls in that cupboard. Imagine that So questions like this often have multiple parts to them. So for imagine the second part, it says that the person went out and bought 4 more plates. How many plates and bowls they have in the cupboard now? So what we would do is we take x plus 4, because we know that they're both plates, and we would put them in brackets like that, and then plus w. The same as if they said, if they dropped, say, a bowl, how many bowls do they have now? It'd be take away the 1, and you put that in brackets. Okay, and that holds those things together that are true for that particular item. All right, let's look at a few more examples where we're using some words in our questions here rather than perhaps symbols. The product of E, F, and 7. So product here means multiplication. So it's E times by F times by 7, and that's going to equal 7EF. Now, the reason it equals 7EF and not EF7 is because we always put the whole number or the numbers first, and then we list the pronumerals in alphabetical order where possible, so EF. So the multiplication signs, the convention is for them to disappear, and we just assume that they're there, and then we place them in that order. Okay. C is divided by 4, and then 1 is subtracted. So C is divided by, and we want to express our division as a fraction. So C is divided by 4, so C over 4, and then 1 is subtracted from that, like this. And finally, the sum of x and 5 is multiplied by 3. So sum, okay, means addition. So x and 5, so x plus 5. And now we want to multiply all of that by 3. So we want to put that in brackets, and then we're going to multiply it by 3. And the way we would write that in a simplified form with algebra is we'd put the 3 at the front, and then we'd write the bracketed element following it like that. Okay, and just like we've seen with up here, where we assume the convention is that there's a multiplication sign here, we assume that we put this 3 out the front of the brackets as a multiplication sign in here as well.